This problem involves manipulating an array int list and thinking about pre and post conditions. We're asked to write a new method for the ArrayIntList class called subListSum that takes a from index and a to index and that returns the sum of the values in that range. We're supposed to include precondition and postcondition comments to describe the method's contract. I think this is easier to understand if we look at some actual examples. So we have a sample list here. I've purposely included the numbers 0 through 6 in sequence so that way these are numbers that are equal to their index, so that we can kind of talk about it without worrying about the index versus the value. But I've included some extra values at the end to make it clear that we are specifying indexes here. We're not specifying the actual values. This is a list that has 10 numbers in it, so this final value has an index of 9. So in this first call, we're asked to find the sum from 0 through 4. Now you might imagine that that would be go from index 0 all the way through index 4, but that's not the convention that we use in Java. In Java, the convention is that the from index is inclusive, so we do include the 0, but the to index is exclusive. So here the 4 is an index that's one beyond the final index we want to use. So the idea is add up things from index 0 through index 4, but not including index 4. So all the things that come before index 4. So that's the to index being exclusive. So we add up 0, 1, 2, and 3, and they add up to be a 6. If we were asked to do 2 through 5, that would be starting at index 2 and going up to, but not including index 5. So 2 plus 3 plus 4, that adds up to 9. When we say 6 through 7, we'd be saying starting at 6 and going up to, but not including index 7. So this is actually a way of saying just the element at index 6, which is the 6 itself. When we say 6 through 9, we'd be saying starting at index 6 and going up to that index 9, that's the final index, but not including the index 9. So 6, starting at 6, going up to, but not including that 19, it would be the 6 plus the 18 plus the minus 4, which add up to a 20. When we say 9 through 9, this is a curious case. So we'd be saying starting at index 9 and going up to, but not including index 9. You might think this is illegal, but actually Java thinks this is a legal call to make. It would be a way of specifying an empty sublist. So we'd be saying starting at 9 and going up to, but not including the 9. So in other words, empty. Nothing is being included, and that's why the sum is 0. So if you wanted to say include the value at index 9 and only that value, we'd say indexes 9 through 10. And this 10 is a curious value because it's actually beyond the highest index of the list. It's the size of the list, and it's actually the index that would be one beyond. So saying 9 through 10 is the way of saying just that value at index 9, which adds up to a 19. I've set up a JGrasp file that has this data in an array. It adds it to an ArrayIntList and then tests each of these different cases. The testing code shows the from and the to index. It makes a call on subListSum and then shows the result. So our task is to add this new method to the ArrayIntList class, this method called subListSum. So I have over here the ArrayIntList class. We have its methods here, its fields here, its constructors are here. So we want to go ahead and add a method here, public method. It's returning a sum, which will be an int, and it's called subListSum. And its first parameter is the from index. Its second parameter is the to index. And so we'll fill in the code here. I'm going to begin by writing code that adds up the entire list. It's a good starting point for this. So it would be a simple cumulative sum task. We'd start a sum at 0. We'd have our standard traversal loop for I starting at 0, I less than the size of this list, I plus plus. We would say what I want to do with my sum is to add in element data of I. We want to add in the ith value from the array, and then we would return that sum. So this is the way we would add up everything in the list. What we've been asked to do is to add up a sublist here, so from a from index to a to index. So we have to alter the bounds of our list, of our loop here. So we want to start at the from index, and we go while I is less than the 2 index. That's kind of a good first approximation of this. It actually turns out this is just the right fix that we want to do. It's somewhat convenient, this rule that Java uses, that we can make these simple modifications. The from index is inclusive, so that's why we do want to start I at the from index. But the to index is exclusive. So we want all the i's that are strictly less than the to index, not going all the way to the to index. So we don't actually include it. We have all the i's that come before. So it turns out this is actually the change that we want to make, is just changing it from 0 size to be the from index and the to index. And this should work. Let's go ahead and compile and make sure we haven't introduced an error. We'll go to our ArrayIntList code and compile this, and that compiles properly. Let's try running it and see what answers we get. And if we take a look at our answers here, we get an answer of 6 followed by 9 followed by 6 followed by 20 followed by 0 followed by 19. And sure enough, if we compare, 6 followed by 9, 6 followed by 20, and 0 followed by 19. So this is a correct solution to the problem we were asked to solve. But the other thing we're supposed to do here is to add preconditions and postconditions. The idea is to be very clear about the contract that we have with any client of this method. So if you want to be able to call sublist_sum, there are some constraints on what you can pass as values for the from index and the to index. For example, you can't give me a negative number for the from index. So that would become a precondition. We would want to say that the from index is greater than or equal to 0. It's not a negative number. That's a precondition. The precondition basically says this is a constraint on the client who's going to call this. It better be true before you call this that the from index is not a negative number. Otherwise, you're not supposed to make the call. The postcondition describes what will be true afterwards. And so we would kind of describe in English, returns the sum of the values from index inclusive, we could have another little comment here, to index exclusive. So we can kind of be very clear exactly what our method is doing. But now this isn't the only precondition here. There's actually preconditions also about the to index and about the relationship between the from index and the to index. This is actually kind of easiest to express in a mathematical way by using a sequence of less than or equal to's. So I'm actually going to turn this around. Instead of saying the from index is greater than or equal to 0, I'm going to change this into saying that 0 should be less than or equal to the from index. Now, what about the from index versus the to index? We saw that it was okay to have from index be equal to the to index. That was the way of specifying an empty range, but not farther apart than that. I mean, the from index should be less than or equal to the to index. So this would be kind of, we'd say the 0 is less than or equal to the from index, and that in turn should be less than or equal to the to index. And we saw that the to index was actually allowed to go all the way up to the size. It could be as high as the size. It doesn't have to be strictly less than the size. It could be equal to the size. That was because it's an exclusive index, so we might end up with something that was actually equal to the size. But this is the Java convention, is that we shouldn't be having a to index that would be bigger than the size, and the from index shouldn't be bigger than the to index. So this is in fact a complete specification of the contract, and then that completes the problem that we were asked to solve.